I manage the data engineering team, and Nabeel is a senior software engineer in the group.
Hello, everyone.
And we also want to thank a few folks who are working with us. We're a really small team. I started working at Vouch about a year ago. There was a single data engineer, Nabeel here, and we have hired a few more folks, and we have started to build a lot of this graph infrastructure. And we'll tell a little bit about that later today, but just want to give a shout out to Shuyu, Shitish, and Jordan. Right. So what are we going to be talking about today? Today, I'll start by giving you a little bit of context about what is Vouch and what kind of data we're working with. We're going to talk a little bit about how we decided to use graph databases and what kinds of things we are building to make our lives easier, because working with graph data is not necessarily as straightforward or as well understood as some other kinds of data. And then some of the challenges that we found, some of the problems that we've found while migrating to this new infrastructure. And while graphs have a lot of really good and useful things, also they're not for free. So what is Vouch? Vouch is a technology-first commercial insurer. We are basically building commercial insurance products for startups. We have a bunch of different partners that we work with. We work with Silicon Valley Bank. We work with Y Combinator, Brex, Carta, a lot of names that you probably are familiar with. We're the preferred insurer for all of their customers, all of their partners. And insurance is all about understanding risk. It's about, can we use data to understand what kinds of things our clients or our potential clients are doing, and understanding what their business is essential to our success. It's something that is core to what we do, and data is how we get there. So we're building the most robust startup risk data set in the world. It's not just a data set about startups, it's about their risks and what kind of risks they're taking on as a company. So we have every single startup, every one of the partners, and every one of the VC firms that they're working with. And of course, that makes for a pretty nice graph. There's lots of connections, lots of data that's embedded in this network. And so when we're talking about understanding the risk in the VC ecosystem, we're talking about what kind of business is a company in. Is this company a fintech company or a healthcare company? And if they're healthcare, are they doing pharma or genomics? What kind of business are they in is a really important question for us. Also, how many people work there? How fast are they growing? When were they 10 people? When did they make it to 50? When did they make it to 100? Those kinds of time series views of where is this company today? Where were they at some point in time? And that also helps us understand how fast they're growing, but how fast is the sector growing? If we're thinking of all the fintech startups, how many people are coming into this space? Being able to understand that is really crucial to what we do. And also how much money they have raised and from who is a proxy for how much risk we're taking on. How big is this company going to get? Because maybe today they don't have that many people, but they just raised a big round. They have $10, $20 million that they raised from some VC. We know that that is going to translate into the company growing. And who are those investors? Who do they usually co-invest with? Who are the people who are involved in these relationships? Who are the people who are involved in these companies? And lots of other information that we can get from this graph to understand the risk that these companies are taking on. And so here I'm going to hand it off to Nabeel to tell us a little bit about our graph and how we ended up coming into this space.
Yeah, so I think kind of building on the keynote from yesterday, given that we're a newer company, we're in that sort of modern data stack type of organization. So we use Snowflake as our data warehouse and have heavily leveraged dbt for transformations in terms of managing a lot of that data model and ingesting data from a lot of different places. I think, as probably is well understood, working relationally is like a lot easier to hire for, and it's like well understood pattern. So when we onboard a data engineer or an analyst, it's very easy for them to contribute to that dbt kind of relational data model that we currently have. But I think as we started doing more exploration as to why we needed to do graph, we really care a lot about where data is coming from, and when we learned about certain facts and understanding the provenance of data and kind of linking all that together just became pretty untenable in Snowflake and in a relational database. And we figured this is kind of where graphs are really going to shine. And so we decided, okay, let's go down the path of graph, even though I think, it's not a path that was naturally kind of what our background was or the background of a lot of the people that you interview for traditional data engineering roles. So kind of some of the problem set that we get. So we are ingesting kind of messy structured data from a variety of different places. So vendors that we buy data from, some proprietary sources, and also client applications for people who apply for insurance with Vouch. And so we get that data into the graph. We're a Python shop, so we use Python, and we've kind of found that RDF-lib is like a really powerful library to make use of in terms of taking a lot of that messy structured data and transforming it into RDF. And so, yeah, I think kind of like a lot of the other talks, we've found that RDF is like a really nice way of translating all these different data models into a single unified model that we can leverage inside the graph. And the other thing that we found is that, using named graph properties and quads, that we found a really nice way of building up metadata, setting up rules, and tracking provenance to understand that where we learned this fact and when we learned about it. And that's become like a really nice feature that we've had in terms of, and we'll talk kind of later, how we use some of that provenance to figure out the correct data about different entities in our system. And the other thing is that, when we were kind of exploring LPGs versus RDF, and I know not to get too much into that, the weeds of that, but we found that, RDF was like really great to get started quickly because there were a lot of existing ontologies that kind of mapped out the ecosystem that we were working on. So we've made heavy use of schema.org because a lot of the properties and relationships about organizations and employees and kind of how many employees you have or where your address is and things like that and locations, they already existed. So we didn't want to, we don't have ontology background. We didn't have budget to go hire one. So being able to leverage existing ontologies to build out this data model was really, really useful. And so, now kind of what Avi was mentioning, a lot of those second order relationships become much easier to navigate because you can do those traversals, in your RDF graph, whereas previously that wasn't really possible relationally.
All right. So I'm going to give you a high-level architecture of how these things are built. So we are using Snowflake as our core data warehouse, as Nabeel just mentioned, and we are building a bunch of internal systems. We are a small company that has an internal engineering team that is building an application to take data about companies that are coming in saying, hey, I want insurance. They are being piped through to our Snowflake data warehouse. All of those systems are set up to pipe data through. And we ingest data from a lot of vendors, as Nabeel was saying, different vendors that have information about startups, that have information about different risk profiles of companies and different kinds of things. We pull all that into Snowflake and we process that using dbt. So dbt, in essence, acts as a templated SQL engine so that we can have some level of modularity between the different pieces, and we can bring all of this together, put those models back into Snowflake, and this loop runs as a batch process all the time. Where things start to get interesting for this crowd is we're using Neptune. We're using Neptune for many different purposes, but to understand the graph, we have to get the data there. And so we're going to talk about two processes today. And there's a lot of other things that we're building in different parts that I'm not going to really narrow into. But from Snowflake into Neptune, we have to somehow create those quads. We have created this process that we're calling Quadify, which is a batch process that will take data from Snowflake, turn those tables into quads, put them into the graph database. And then on the other way, we summarize that data and create tables from these snapshot views of knowing everything that we have in the graph right now. Can we find some subgraph that we have some information about, some subgraph that we want to compute some values and understand better, and we turn that into a single row in a table that people can then go and access in the Snowflake side. And so from Neptune, we expose a UI that we're building on top of Streamlit, which is a tool that's actually recently got acquired by Snowflake, really interesting company. We have a Sparkle endpoint, and we have an API that allows us to have people access stuff programmatically. They can say, hey, I have this ID of this one company. They can send that to this API and get every single piece of information we have about that company or that set of entities that match that ID. Separately, as Nabeel was mentioning, we have Mode as our BI tool. Our analysts are not really accessing the graph directly. They're accessing via these tables that we're summarizing into Snowflake. So really the core of our system ends up being the information that we put back into these relational tabular views. And we're going to talk a little bit about how we do that.
Yeah, so I think we're going to just kind of go through a little bit like the journey of data. And I think one sort of distinction that we have versus some of the other graph models that we've seen kind of discussed here. So here's an example. A company is applying for insurance with Vouch. They tell us, on July 1st, 2021. So the source is the company application. The date we learned about this is July 1. And they tell us these, amongst other facts, but they've told us these two facts: how much money they've raised, $8 million, and the number of employees they have, 12. So then we have an entity resolution process. We'll get into that in a second. And we match this to 2 different vendors who have given us information as of May 1st, 2022, and we've added some more facts. So we have one vendor telling us that this company now has actually raised $10 million and has 18 employees, and another vendor is telling us that we've raised $11 million with 17 employees. So I think unlike some of the other graphs where it's like there's one sort of true number of like headcount or whatever, and you're linking different entities, our graph model is actually representing sometimes the same piece of information from different sources. And so we have this process that we'll get into a little later about determining what is the actual true number of employees or the total amount raised that company has. And we're sort of using graphs to help navigate that process. So the kind of thing is, we're now at time for renewal. We want to figure out which of these values is actually the correct value so that we can quote this particular client. So, I think some people have mentioned, oh, it's very easy to take tabular data and convert it into graph data. I think for us, this was a bit of a process. And so we've kind of built some tooling around this because we figured a little bit easier than to maybe go to a vendor or something like that. So we start with and kind of have these configurations that are very easy to add and configure to translate tabular data into RDF graph data. So this is like a kind of pseudo config that we would have. So, the name would be the vendor, the predicate mapping would be taking each column in a tabular view and representing it to a specific RDF predicate, kind of using the RDF lib syntax. So sto.name would be the schema.org name predicate, employees would be the number of employees, and the subject for each one of these facts would be that ID key. And then the date field would we use that to define the named graph that each one of these facts would go into. And so we use Airflow to do our orchestration, but we basically have a batch job that goes through each row in our data set, assigns a subject, creates a graph URI, which is the sort of combination of the source name and the date modified. And then sort of if the row is a valid row, depending on the predicate, we create that quad that we add into our graph. And so this allows us to not only store the fact, but the metadata about it. Neptune doesn't support RDF star, so this is sort of our way of kind of capturing that piece of metadata.
And importantly about this last piece, when we're talking about these configs, we have one of these configs for each of the tables that we're trying to put into the graph. And so it makes it really easy to scale very quickly because adding one more table, one more model ends up being just adding one more of these configs.
So this is like a quick example. So on the left would be like some different Snowflake tables, and like each data model in Snowflake has like different ways of representing these types of data. And we have the quantify process that will create these facts into different named graphs. So you can see here for ID 123, that's the subject. The different columns represent the different predicates. The objects are the values. And then the named graph is kind of the metadata of when we learned it, when that date updated, and which vendor that data came from. So the second piece of the pie is, as we say, we have this like entity resolution process. So we kind of need to determine if these 2 entities are the same, and we generate same as quads to sort of link these different records together. So each connected component in this graph would resolve to a single entity. So if you look here, different vendors, we sort of link these all together. And so we generate an ID as a product of the connected components of the different entities, different companies that we have in the data set.
Quick question, did I understand this correctly? When you get a new update from vendor 1, you create a new URI for that? And then do the same as, or is it always consolidated with one vendor and one company?
So when we get a new batch from our vendors, we will create a new named graph that has the vendor name, the source, as well as a date on when we got this piece of information. And every fact that we got on that batch of information gets uploaded to that graph. So we have all these snapshots in time divided in different graphs.
So the subject would be the same.
And separately, we have the entity resolution, the same asses that we're creating go into a separate graph of its own.
And so the problem that we end up getting is we have these connected components, and each vendor is telling us something different about the same fact. So vendor 1 is telling us we have 18 employees, the next one is telling us 22, and vendor 3 is telling us 20. How do we reconcile that piece of information is a key problem for us in terms of determining how many employees this company may have. And that's where summarization comes in, or this is a process that we've had. So we have a cluster of companies. We've determined that they are, in fact, the same company. And we want to figure out which value for a specific predicate is the correct value. So I think like we could call this like an inference that we're sort of making, but we don't materialize these inferences. We calculate them at runtime and surface them to users, whether that be through API or kind of what Avy was mentioning by a batch process that creates a tabular view that gets consumed into Snowflake. But this is effectively an inference that we're trying to make. So we basically define a set of rules for a given predicate that will take a group of facts and returns the correct one for a given subject. So here's like a sample config that we may have. So for, let's say, the total equity predicate, we might define a summarizer that says just take the largest value. We have a relatively high degree of confidence in our sources. These numbers only go up, and so we just take the largest number. The name, we might say, actually, we do think like vendor 2 is the best at identifying names, so we'll just take the name from, and rank the sources and take the source that we think is the best. You could imagine we also take like the last value that we've consumed. So there's a lot of ways that we can define these rules. And so this is maybe like some sample code where we have a predicate, we get all the quads for a specific predicate, we summarize, and then we summarize it to get the best value. So kind of what I was mentioning, our analytics teams are very SQL focused. Our BI tools kind of work out of the box with SQL. Teaching Sparkle is not really all that practical for a lot of our newer analysts. And, there aren't like ways to build simple dashboards on top of a graph. So creating a tabular view of a specific look of the graph has become pretty important for our teams to be able to do. And for our go-to-market teams, we also have like reverse ETL tools that consume data from Snowflake, which wasn't modeled in our high-level architecture. So, pushing data back into Snowflake is really important. So we've created a simple way that you can write a Sparkle query as a config and define like a post-processing function that will take that RDF data that's coming out of your Sparkle query and kind of output it into a format that's consumable by Snowflake. And so one of these is like we create a summarized company view where every company in our data set, we return the row of the current view with all the summarized attributes or defined on a predicate level. So some of the challenges that we've run into, Sparkle is not something that we had any background in. And so having to learn a new language is something that was a bit tricky. And, when you Google questions about Sparkle, the Stack Overflows are oftentimes many years old and there's not a lot of back and forth on them versus SQL where there's a ton of like a very much larger community and a lot more robust support. So I think that was a bit of a challenge. And there's been a bit of a learning curve in terms of kind of understanding how to use Sparkle. I think for us, we've also run into Neptune is really good for like quick transactional queries, but for larger analytical queries, we've had some issues a little bit. And a lot of the stuff we want to do is like, give me everything about like a big subgraph. And that's sometimes been proving to be a little bit challenging at times. And the last thing is, schema enforcement has been a bit tricky. I think it's kind of like, it's really nice that with RDF, you can and with graph databases, you can kind of just throw things in. But we haven't had the capacity to invest as much in modeling and creating like strict rules around our models. And so kind of, I think a next step for us is to start investing in things like Shackle and kind of really trying to create better shapes of our graph. So that way users can have more clear expectations of what they would get when they query the graph. But right now this has been a bit of a challenging. And so we don't have an ontologist on staff. So this has been a bit of a tricky area for us.
And so with that, we can move on to where we're headed. So we talked a little bit about this entity resolution process. Right now, entity resolution that we're doing is mostly around companies and VCs. There's all sorts of other partners who are not necessarily startups in the ecosystem. We want to be able to understand who they are as well, being able to generate entity resolution for different kinds of entities and using more data to pull this in. Right now, we're doing something that's relatively naive, using websites and names, and that's about it. We can also use the metadata embedded in the graph itself to do more of this kind of subgraph mapping into these IDs, and we're starting to do some of that work. We're also starting to mine the network itself, being able to say that because you got money from this investor who usually co-invests with this other investor, and usually when the two of them are in the same deal, it's likely to be a fintech company because that's the kind of thing they invest in together. That's something that we can understand for a couple of investors, but there's tens of thousands of them. So using the network itself to kind of understand what is the embedded metadata is something that we're really interested in. we're also going to start working with more of these entity types and more modeling, as Nabeel was saying, using Shackle, using other tools like these. And we're starting to build a feedback loop for non-technical users. So that Streamlit application that we were discussing earlier, if I'm on the phone with a company because I'm a sales representative and they tell me, hey, there's an unannounced round, we need insurance right now, and we just raised another $10 million, our data in the graph might say, hey, this company has $2 million raised. But I, the BDR, the salesperson, should be able to put that into the graph. And I should be able to create a fact, and the system behind the scenes knows how to take that and use the summarization rules to say, when we were on the phone with someone, we got this fact at this point in time that might not be in one of the other sources, but we know it's a really high value fact as well. And being able to weigh those differently is something we're starting to build out. And there's a lot more that we're building. And because of that, we're also hiring a bunch of people. We are trying to build a really large group. Right now, we have like 4 or 5 people on the data engineering side. We have folks coming in for data science, analytics, but really all sorts of different roles in the ecosystem. And with that, I think we're ready to take some questions if you have any.
So, let me just. Thank you guys for a very good presentation. Can you tell us a little bit about how sensitive the risk on the insurance side is to some of these variables and the temporality of it? Let's say somebody raising a round, right? Applying for insurance because now perhaps they're getting out of the seed mode or stealth mode, they're going into first round of institutional investment. They need some type of insurances, right? And they come to you. The past, right, when there were 2 guys in a garage until they got the Series A funding, right? Now they're a real company, right? Maybe you're talking about further rounds. I mean, a little bit of the temporality and how the risk affects the risk of the policy. What's going to be my quote? 10% more, 20% more? I don't know. That's what I want to find.
That is exactly why this is such an important piece of our toolbox. Because when you come in and you're a small startup and you have 2 people in a garage, you get your first policy, the numbers are going to be a lot lower than if you come back in a year later, you've grown, I don't know, 2, 3x, you have way more people, you have big contracts that are lining up. That getting the clients ready for that kind of bump in premium is something that we're trying to build out, which is why when someone's coming up for renewal, we have to know how much they have grown. And we're doing that by getting this vendor data and understanding who they are and how they have changed in their business. Even though they're our current clients, we want to make sure that our sales representative, our insurance advisors can go and have a conversation with them and say, hey, you have grown 2, 3x. Your premiums are not necessarily going to grow that much, but they will be higher than what you had before. You have to prepare the client for those conversations. And so that's in part why we're doing this.
And I'd say one attribute of the startup universe that's a little bit interesting is that it's very much like a power law distribution. And so you do have these like large super nodes kind of like in the like broader ecosystem. And so I think graphs really do shine in sort of identifying those like mega relationships, which become like a lot more than kind of other places that are just more fragmented.
You mentioned that you upload in the graph every time you get data from vendors, or have you thought about how you're going to improve that data, how you're going to filter that out? Because eventually you're going to run out of space, or the system will be super slow, or what's your plan on that?
Yeah, so something that we're lucky with in some way is that the startup ecosystem, for what it's worth, is relatively small in terms of number of entities. We're talking about maybe 1 million startups in the US who are live at any point in time, probably less depending on how you define what a startup is. And so in part because of the data volume being small, we can probably continue to load new data in without too much of a hassle, but also because we are, at the time that we're creating these squads, we know which source something came from, and we know how long ago it was put in there. We could say, hey, we're going to start dropping data that is repeated quads. Also, Neptune does deduplication on the fly. So if the same fact gets uploaded to 2 different graphs, it doesn't necessarily hold both of those behind the scenes. It doesn't get persisted. So that's maybe a little bit of the solution is baked into the tool itself. I don't know if you want to add anything else.
No, I think that's great.
So we've a couple of more minutes. I'm going to take one question online, and I think we've one more question here in the room. So, first of all, great feedback, great presentation. Here's the question: do you use time evolution views? For example, the history of employees at a startup. Interested in hearing application side and underlying challenges, for example, multiple data sources.
Yeah, so I think on the temporal side, we're a little bit weak. I think that's like an area we were really interested in the talk yesterday about temporal graphs. I think that's like a little bit harder for us in terms of like deltas over time and like monitoring that, I think is an area that we struggle a little bit with. And it's something that we are very much interested in getting a lot better at because I think it's critical for us.
How are you going about that?
So one of the things that we're doing right now is the two things that we care about the most that are kind of proxies of what kind of company you are. Once we know the classification of your company, the next two things are your headcount and how much money you have raised, because that's kind of a proxy for the size of your company and the size of the risks that you're taking on. And so those two values really change a lot over time. As you were mentioning earlier, startups really can grow a lot. That growth rate is a signal to us at time of renewal, but also it's a signal for how much this company is going to continue to change and how this company is going to do as a potential client in the future. And so understanding those two facts and how they change is key. And we're currently just taking, basically like pull out every one of the triples that matches this attribute after we have done that summarization process at this point in time, basically taking windowed views of what that looks like, and we can generate basically line charts on top of that.
Yeah, so kind of building it into the summarization as like a post-summarization inference is kind of how we're thinking about it at the moment.
Great. Thanks.
Great presentation, guys. Still great presentation. ID policy. How do you generate the IDs for the source data that you get, and how you manage the IDs on the linked entities, and how you ensure permanence between the updates?
Yeah, so the IDs that we get from the source entities, the sources, the vendors, or our internal system, they all assign IDs. So we just sort of pass that ID through. So if the vendor gives us ID 123, that's the ID that we use for the source data. As far as the ID of the linkage, we sort of take a hash of the oldest one. So that way, like, it's consistent within the cluster.
And importantly, we don't use the graph for our production database that is serving this is an application, this is a policy, this is a quote. That is a separate system that is owned by the platform engineering group within the company. And we ingest that into Snowflake, and it's one of the pieces of information that goes into the graph. So basically, if you come in as a company, you apply, you get company ID 123 for your company. Later on, we will go and say, there's all of this data from vendors that we're pulling in. We're mapping those IDs from those vendors to company 123 in our system. And so the same as is not just between vendors, it's also between vendors and these companies that we have in our internal database.
Okay, permanence between updates and changes, IDs, this is the, thank you, we'll discuss this later, thank you.
Sounds good.
Okay, everybody, so great presentation, fantastic questions. Thank you very much for the session.
Thank you very much, and please find us outside, and we'd be happy to answer more.